Welcome to qnawire.
All right, so what we have here is a combination of a Newton's second law as well as a one-dimensional kinematics problem. Before we get to any intense math, let's translate these English sentences into actual equations by listing the quantities that are given to us to help us figure out what we're supposed to do. So the first number that's given to us is the mass of the ice skater, and that's 68.5 kilograms. The second number that's given to us is the initial velocity, so we'll call that v naught, and that's equal to 2.40 meters per second. So the third piece of information that's actually given to us in this problem is the final velocity of the ice skater, because we're told that he or she comes to rest, so they have a final velocity of 0. And then the fourth and final piece of information that's given to us is the time interval over which the force is acting. So let's call that delta t, and that takes 3.52 seconds. Okay, so we are going to indirectly find the force by first finding the acceleration. So at the very end of the problem, we're going to apply Newton's second law, which is to say that F is equal to ma. Force is equal to the product of mass times acceleration. And then we're assuming that this is going to be a force, a constant force that's being acted over a time interval. So we can just use the definition for an average acceleration over time interval, and that's going to be the change in velocity divided by the change in time, with specifically a change in time being a change in velocity being the final velocity minus the initial velocity. And then we'll just leave the change in time, delta t, alone on the bottom. And then from here, we have finished writing the acceleration in terms of quantities that were already given to us. So we can go ahead and substitute this into Newton's second law in order to say that the force is going to be equal to the mass being multiplied by the substituted form of acceleration, v f minus v naught over delta t. Great. So that's actually what our answer looks like in symbolic form, but we do have some numbers to plug in, so I'll go ahead and do that now, with the mass being equal to 68.5, quantities in parentheses, final velocity being 0, minus 2.40, close parentheses, and a time interval of 3.52. So to three significant figures, this final answer is going to be negative 46.7 newtons, and with a negative sign arising because this is a frictional force, and friction will always oppose the direction that the ice skater is moving in. So that wraps up this problem, and we're done.